In this presentation, I am going to explain the previous GATE questions and answers for the year 2023, and the topic covered is power electronics. Now let us see the first question, that is 2023 GATE question, and that carries 1 mark. Question 1. The chopper circuit shown in the figure 1 feeds a power to a 5 ampere DC constant current source, and the switching frequency of the chopper is 100 kilohertz. All the components can be assumed to be ideal. The gate signal of the switches S1 and S2, this is the gate signal for the S1 and this is the gate signal for the S2, are shown in the figure 2. Average voltage across the 5 ampere current source. What is the average voltage across the 5 ampere current source? That is to be calculated. And the options are A 10 volt, B 6 volt, C 12 volts, and D equal to 20 volts. Now coming to the circuit here, the input voltage equal to 20 volt, and here the constant current source is equal to 5 ampere current source, and here the two switches S1 and S2. When S1 is conducting, you can say that the voltage at this point is equal to same as the source voltage, or that is equal to 20 volts. Or even when this diode D1 also conducting, this point is connected to this one, you will be getting 20 voltage. Or if S2 or this diode, any of the devices conducting, this voltage will become, of course, with respect to this one, 0 voltage will be getting. Now coming to this one, when S1 is in this is the S1 switch here, and here from 0 to 3, that is from 0 to 3 here, that is 0 to 3, S1 is turned on. S1 is turned on, this voltage is be same as this input voltage 20 volts. For from 0 to 3, the input voltage equal to 20 volt. And from 3, you see that one here, even though from this duration, this is being switched on, we'll be getting a 0 voltage. And the next 20 voltage will be available only at the instant 10. Here, next instant 10, this is turned on, or the S1 is turned on, and you'll be getting a voltage here same as the input voltage 20. Therefore, this is the voltage that is available across the constant current source, that is 20 volts from 0 to 3, and from 3 to 10, 0, and that is repeating. The question is that what is the average voltage across this constant current source? To find out the average voltage, let us see that one. The condition, as I already explained, when switch S1 or D1 are on, when either S1 or D1 are on, this voltage is same as the input voltage 20 volts. That is V0 equal to 20 volts. When either S2 or this D2 on, then the output voltage equal to, since this point is being connected to this one, the voltage at this point with respect to this one equal to 0. Therefore, this is a plot as such, and you have to find out what the average voltage. In order to find out the average voltage, you take this area, this is the area, and that is being distributed over this length or over T, 10. That is time period, that is 10. Therefore, 20 into 3, that is the total area of this one, that divided by this time, or 10. 20 into 3 divided by 10, that is equal to 6 volts. Therefore, the average value of this voltage across the constant current source equal to 6 volts. Therefore, the answer is option B. Now, let us see the second question of 2023 GATE question that also carries 1 mark. Second question, a semiconductor switch needs to block voltage V of the only one polarity be greater than 0 during the off state as shown in the figure 1, that is as shown in the figure 1, and carry current in both directions during the on state as shown in the figure 2, current both directions. Which of the following switch combinations will realize the same, these two conditions? Now the option A, B, C and D are given, and we can see that from the given configuration, the current flow is in both direction or bidirectional. The switch also has a drop voltage, and the switch configuration in option A, if you see the option A here, this will pass a current in this direction, and this can flow current in the opposite direction. Therefore, as well as option D here also, you can see that here through this it can carry a current in this direction, or through this diode it can carry in the reverse direction. For A and D can provide the bidirectional current, hence the correct options are A and D. The options A and D are the correct options. Now let us see the third one, that is 2023 GATE question that are carry 2 marks. The circuit shown in the figure has reached steady state with thyristor T in off condition. Assume that the latching and holding current of the thyristors are 0. The thyristor is turned on at time t equals 0 and the duration in microsecond for which the thyristor would conduct before it is turned off is question that is round off to the 2 decimal places. Therefore, this is a circuit in which this is a voltage source 100 voltage and this is a thyristor and this is a load which is equal to 4 ohms and this is an LC circuit which is C equal to 1 microfarad and L equal to 4, it is equal to microhenries, and initial, that is at the time t equals 0, this is being this is turned on, or just before t less than 0, that is that this is not turned on. Therefore, that equivalent circuit is this one. That is before turning on the SCR, this is the equivalent circuit, and in that case the capacitor is being charged to this voltage same as the source voltage. So that VC at 0, at time t equals 0, the capacitor voltage is equal to 100 volt. And of course, this is the inductor and this is the resistor. Oh, this is the circuit diagram as time t is less than 0. Therefore, at time t equals 0, the thyristor is turned on. Therefore, in that case, once thyristor is turned on, the equivalent circuit is shown here. Because already it is voltage has been reached to 100 voltage. Therefore, that is represented as this 100 voltage. And here that this one, and this is a capacitor and this is the inductor. And the thyristor is conducting me, this is switch, closed switch as such, and this is the load 4 ohm resistance. Therefore, this is the equivalent circuit as time t is more than 0 once the thyristor SCR is conducting. Therefore, here the total current, we can see that one, the total current through a thyristor IT is equal to what is this current I0 plus what is this current IC. For this current plus this current is equal to the total current IT. Once the current through the thyristor is going 0, that is get turned off. Therefore, we have to find out the instant at which or the time at which it is getting turned off, or once the current is going 0. Therefore, we have to solve first one this loop, this LC circuit, that is to be the current waveform. You have to find out, and this current is always, is you know that load current is given by, it is equal to 100 divided by 4 ohms, or that's equal to 25 amperes. This load current through the resistor, the current equal to 25 amperes. But you have to derive what is the current flowing through this loop. Therefore, that will be seeing in the next slide. Now, continuing the same problem here. Now, as I told you, when the thyristor is turned on, this is the equivalent circuit. And of course, this is the current, load current, which is equal to 25 amperes, which is equal to 100 divided by 4. And the total current through thyristor is equal to the load current plus this capacitor current. Now, this is the load current. And of course, we have to derive what is this current, this LC loop current. In order to that one, we have to apply the Kirchhoff's voltage law for this loop. Therefore, that is equal to L di by dt plus 1 by C integral I dt equal to the source voltage Vs, which is equal to 100 voltage. For taking the Laplace transform, we will be getting L into SIS minus the initial value of the current plus 1 by C IS divided by S plus initial charge Q0 divided by S, that is equal to Vs divided by S. Or initial value of the current as well as initial value of the charge equal to 0, we'll be getting, assuming that IS into SL plus 1 by CS equal to Vs by S, or IS is equal to Vs divided by L into 1 by S square plus 1 by LC. Or we have to take the Laplace transform of this equation to find out what is the current IT. Or sorry, that current, what is this current? Actually, this current equation, that's nothing but the capacitor current. We are defining it is equal to IC. For to derive, you have to take Laplace transform. That is one thing is that if you look into this one, if you define this 1 by LC, 1 by root of LC as the omega naught resonant frequency, 1 by LC equal to omega naught square. Therefore, here 1 by S square plus omega naught square. Now assume that we are multiplying omega naught the numerator and denominator, which is equal to 1 by root of LC. For then this part is equal to omega naught divided by S square plus omega naught square. Now, if you take the inverse Laplace transform of such a equation, that is omega naught divided by S square plus 1 by S square plus omega naught square, the inverse Laplace transform is nothing but sine omega naught t. That is why we multiplied numerator by omega naught. Now, since we have multiplied numerator omega naught, we have to multiply denominator also omega naught. Therefore, omega naught equal to 1 by root of LC. Therefore, 1 by root of LC, then this will become Vs into root of C by L into the inverse Laplace transform equal to sine omega naught t. Therefore, this is the equation that is represented this one. This is the equation that the current equation through this loop, which is equal to nothing but we can say that is equal to capacitor current IC, which is equal to IC, and where omega naught equal to 1 by root of LC, which is called the resonant frequency of this LC circuit. Therefore, here now we have to substitute these values like this voltage equal to 100 voltage into root of here C value equal to 1 microfarad and inductance 4 microhenry, substituting sine 1 by root of LC 4 into 10 raised to minus 6 into 1 into 10 raised to minus 6, then will be 50 sine 500 into 10 raised to 3t. This is the equation for this current. Therefore, the current equation for the current that is flowing through this one, this is the sinusoidal current that is flowing through this loop. Anyway, once more is that this current through the switch is summation of this load current I0 and this current that is shown here. This current is nothing but this is the load current, which is equal to 100 divided by 4 or 25 amperes. This one plus this equal to that. This is the total current to the device. Therefore, even though the current at this instant, the current through the this path, so that is this one, the current through this path is going zero. Still, there is a current through the device because there is a load current is there. That is why there will be current. And here, one more thing is that the peak value of this current that is equal to Vs into root of C by L. And this duration is given by, that is equal to, the time is equal to pi by omega naught, where omega naught equal to 1 by root of LC. For this duration equal to pi by omega naught. Therefore, the device is getting turned off once the current through the device is going zero. Therefore, at this moment, the current is not zero. Now, to make that is still this, there will be a current, that is the current through this loop that is going negative. The current going negative means that now the current is in the opposite direction, and here the load current is there. Once the current, this current is reaching to the load current, or once this current, that is opposite current is current flowing in this direction, same as the load current, then the device current will become zero. That is at this instant, you can see that one, this current, reverse current that is equal to the load current, that is, then the device current or this current plus the load current is equal to zero, then the device current equals zero at this moment. Therefore, here the device is getting turned off. Therefore, here this is a pi by omega naught. Next, we have to find out what is this duration that we'll be seeing in the next slide. Now, continuing the same problem here, 2002-3 gate question as such. Here, as we have seen, here 100 volt is there, and when device or the SCR is conducting, this is the equivalent circuit, and the total current through the SCR is the load current plus whatever the current flowing through the loop. Therefore, this is the current flowing through the loop. Once this current that is initially it will positive, at this instant, after this one is going negative, meaning the current is in opposite direction. Once that current is same as the load current, the net current through the device is zero. That is that this instant, the load current is same as this current, then the current through the device is zero, that SCR is getting turned off. Therefore, we have to find already this is equal to pi by omega naught, where omega naught equal to 1 by root of LC, and then this duration we have to find out. What is the duration? Coming to that one, I naught equal to 100 by 4, 25 amperes, and the total current through the thyristor equal to this I naught plus whatever this current, and IT equal to 0, that this current equal to 0 once this current is equal to minus, or this current is equal to minus 25 amperes. Once this current is going, that is what, once the current through this path that is going minus, the 25 amperes, the net current through the device or the SCR is equal to 0. That is minus 25. I equal to minus 25. Therefore, the total time is equal to this pi by omega naught plus this angle theta. Now we have to find out what is this angle theta. To find out angle theta, the instant at which this is reaching to this value, 50 is given by, this is equal to 50 sine omega naught theta, that is equal to this current, load current, which is equal to I naught. Or from this equation, theta equal to 1 by omega naught sine inverse 25 divided by 50, where I naught equal to 25, and then 25 by 50, or theta equal to pi by 6 omega naught. For this duration equal to pi by 6 omega naught, and this duration equal to pi by omega naught, and the total duration is equal to pi by omega naught plus pi by 6 omega naught, which is equal to 7 pi by 6 root of LC, or substituting that one, we'll be getting 7.33 microsecond. Therefore, the time at the time, that is 7.33 microsecond, this device SCR gets turned off. The reason is that at that instant the current through the device or the SCR is changing to 0 ampere and device is getting turned off. Therefore, the summation of these times, pi by omega naught and it is equal to pi by 6 omega naught, is the total duration, which is equal to 7.33 microseconds. Now let us see the fourth problem, that is 2023 gate question that carry 2 marks. Fourth problem is the single phase rectifier consisting of 3 thyristors T1, T2, T3 and the diode D1 feeds a power to a 10 ampere constant current load. Constant current load. Here T1, T3, T2 and the diode D1. Constant current load. T1 and T3 are fired at an angle 60 degree. T1 and T3 are fired at 60 degree. And T2 is fired at a firing angle 240 degree. The reference for alpha is positive zero crossing, that is it is taken from here, zero crossing point of Vn. The average voltage V0 across the load in volts, what is the average voltage across this one? That's a question, and that is to be rounded off to 2 decimal places. Now let us see the input voltage at this point. The voltage at this point with respect to this one is shown this one. So dark sinusoidal wave form. And if you see the voltage at this point with respect to this point is what is the dotted one. And this is T1, this is T3, this is T2 and this is a D1 and this is a constant current source. Now at firing angle alpha, T1 and T3 are fired. Therefore at firing angle alpha, T1 and T3 are fired means the path is like this one. It is comes to this one, it is coming like this one, going this one, it is returning back like this one. Therefore, here the voltage is same as the input voltage. Therefore, at the angle alpha, the output voltage is same as the input voltage. At pi radians, this voltage is going 0, and this voltage is, we can see that after that one, this is going negative, mean though this voltage is going positive. Or once this going positive, the diode is getting forward. Even though, firing angle is not applied to this, signal here. This diode is start to conduct. Then what happens is that this is not get turned off. Both these two that is D1 and T3 are conducting. That is duration D1 and T3 are conducting, and that way the voltage across this one equal to 0. Therefore the voltage will become 0. Therefore at an angle here which is equal to pi plus alpha. Pi plus alpha means it is equal to alpha equal to 60 and pi 240. It's 240 degrees. The device T3 is fired. Already D1 is conducting, T3 is fired. Then this is getting turned off and the path is now like this one through this diode and is returning back and through this T3 and is returning back. Therefore, the voltage at this point is nothing but the same as the dotted one. Therefore, you will be getting this voltage, and that until the next firing of the switches T1 and T3, that happens when 2 pi plus alpha. Therefore, this is the waveform of the average voltage across the constant current source. The question is that what is the average voltage? You have to find out what is the average voltage across the constant current source. Let us see in the next slide that one. Now continuing the same problem, that is 2023 gate question, in which this is the input voltage and here this is the output voltage, and we have to find out what is the average output voltage. To find out the average output voltage, that is V0 average equal to, we are taking 1 by 2 pi integral alpha 2 pi Vm sin omega t plus from here to here pi plus alpha to 2 pi plus alpha. Of course, that is equal to, this one is equal to minus Vm sin omega t d omega t. And if you take, it is equal to here, if you take 1 by 2 pi integral alpha 2 pi Vm sin omega t d omega t minus pi plus alpha to 2 pi plus alpha Vm sin omega t d omega t, or Vm by 2 pi sin omega t minus cos omega t alpha 2 pi minus cos omega t alpha pi plus alpha to 2 pi plus alpha. Then Vm by 2 pi, here cos alpha minus cos pi, here it is equal to cos pi plus alpha minus cos 2 pi plus alpha of Vm by 2 pi cos alpha minus 1 plus 1 minus cos pi plus alpha minus cos alpha. Again, this also equal to minus cos alpha. Therefore, here it becomes minus of minus cos alpha means minus 2 cos alpha plus cos alpha 3 cos alpha plus 1. For Vm by 2 pi into 1 plus 3 cos alpha, or substituting for that voltage Vm, which is equal to 100 volt, 100 divided by 2 pi into 1 plus 3 cos alpha equals 60, 3 cos 60, which is equal to 39.79 volt. For the average voltage across the constant current load, which is equal to 39.79 volts.